Welcome. The Office of the Chief Data Officer and the Texas Department of Information Resources are pleased to offer this course, Data Visualization with Tables. In this course, we will talk about the difference between tables and charts and graphs, and when tables may be the appropriate visualization format to use. We'll also discuss some best practices to consider when designing those tables to best present analytic results to your audience. Data visualization is the graphical representation of data and information to organize, simplify, and clarify data. Visualizations transform raw data into a structured format for efficient analysis. They present complex information in a clear and concise manner, highlight trends, and identify relationships. Data visualizations should be designed with your audience or customer in mind. It's important to talk with them to make sure you understand what they need and how they will use the information before you begin your analysis and visualize the results. While we might think a chart or graph is the best way to visualize the data, oftentimes a data table will meet the need. For the purpose of this course, a table is defined as a visual representation of data that presents information organized in columns and rows for easier comprehension, where the data is often grouped by categories and aggregated or summarized. Each row in a table typically represents a single record or entry, while each column represents a specific attribute or variable related to those records. Tables help in organizing, comparing, and analyzing data to make complex information more understandable. They are a powerful tool for simplifying intricate datasets to aid in decision-making processes and achieve desired outcomes. Visualizing data with tables, charts, and graphs is an effective way to help get your main message across in a clear and concise manner. They can minimize the risk of confusion and provide information that leads to actionable decisions. But what is the best format to present your data? That depends on your audience and what type of information they need. Tables are a powerful way to summarize and compare data in a visual format. In a table, data is presented in columns and rows, where numerical values are often grouped by categories and aggregated to summarize the data. They provide an easy way to sort, filter, and manipulate the data and can provide analytic information, such as totals, averages, and percent changes. Presenting data in a table format is useful if your audience needs to examine individual values, do single comparisons, or combine the data with other data. Data is best presented in table format when your audience needs precision, details, or more than one unit of measurement or analysis. Charts and graphs, on the other hand, allow the audience to see important highlights at a glance, rather than having to sift through many columns and rows of data, and they are useful for revealing patterns and relationships within the data. Your audience might want charts and graphs so they can quickly make multiple comparisons, see relationships between variables, or look at trends over time. They may also want to see how close their program is to achieving desired goals or outcomes. In these cases, visualizing data with charts and graphs may be appropriate, and we will go into more detail about charts and graphs in another data literacy course. You don't always have to choose one type of visualization over the other. For example, it is a good practice to include data tables within interactive dashboards. While charts and graphs allow for high-impact communication of the big picture, tables provide the details to explore the data on a deeper level and to clarify the broader message. Providing tables along with charts and graphs is also important for visually impaired users who must be able to access a textual equivalent of the chart or graph without the limitations of embedded alternative text. Every time you create a table to represent the data, you will need to make certain design decisions to ensure you get the point across in a direct and succinct manner for maximum comprehension and benefit. We've already discussed certain principles of design in the course, Data Visualization Design Basics. However, there are other design principles specific to data tables you should also consider. For the rest of this course, we will talk about ways to arrange your data within the table. The use of appropriate alignment and formats. The best use of borders and lines. The benefits of white space and fill. Formatting titles, labels, and notes. And things to consider to enhance readability and accessibility. One of the first decisions you will have to make when designing a data table is how to arrange the data. For every table, you'll need to determine the best layout or order of your columns and rows. Think about what you want to highlight or what is important in the data and choose an arrangement that best displays that information. For example, each row in version 1 of the table displays a department expense type and the dollar amount spent. Rearranging the table and adding a total column, as displayed in version 2 of the table, makes it easier for the audience to see the comparison in expenses between the departments, as well as the overall totals. If your audience needs to compare expenses between departments, version 2 is a better arrangement of the data. The order of your columns is also important. Generally speaking, organize your columns in a reading order from left to right. Descriptors of categories or groups go on the left side of the table, while numbers go on the right side of the table. However, the order of the columns should reflect the needs of the audience, so make sure you consult with them when planning the layout. Place variables the audience wants to compare close together and in a logical order. For example, in this table, the column for actual makes more sense to be to the left of the column for target. By placing the actual column closer to the target column, the audience can quickly see what actually happened compared to what was expected to happen, and the other columns are easier to interpret and therefore more meaningful. If you are presenting data that includes a time series, such as a range of months or years, a best practice is to arrange the columns in ascending order so that time moves from left to right. How you choose to order or sort the rows in your table is also important. Generally, sorting rows by the data in the first column is logical and a good practice, but you may also choose to sort the data according to another column of data you want to highlight, such as your totals column. For example, your audience may need to know something about a specific county. Presenting the information sorted by county name allows the audience to locate that specific county quickly. In another case, your audience may be interested in the most populous counties. Presenting the data sorted by total population allows the audience to see that information at a glance. If your data contains ranked order information, a best practice is to sort the data based on rank from first to last, best to worst, or top to bottom. For example, this table is sorted by department name. Sorting the data by the ranked order makes it easier for the audience to see which department is first, which is last, and to more easily compare the differences between departments. Conversations with your audience or customer before developing your data tables will provide some insight on how to sort your columns and rows to best highlight the information they need. The alignment and format of the data within your tables is also an important aspect of making it easier for your audience to read and understand the information. The proper alignment and format of the data within your columns depends on the type of data contained in those columns. For example, numbers should be aligned to the right so differences are more easily detected. Numbers should be formatted to include commas and percent signs when appropriate. If your numbers have decimals, make sure you are consistent in the number of decimal places. Text and dates should be aligned to the left to make the information easier to scan, and dates should have a format that makes the length consistent. Numbers that may have leading zeros, such as county codes or customer identification numbers, should be aligned to the left and formatted as text so the leading zeros are not lost. Centering data within a column is generally discouraged, as it forces your audience to work harder to find the beginning of each line, especially for those with visual impairments or dyslexia. However, centering data within a column may be appropriate if the data in each cell is the same length and the column name is long. Column headings should have the same alignment as the data within the column. Within the cells of the table, you can remove sets of zeros in very large numbers to reduce visual clutter. However, don't forget to add a note or some other designation in your data table to indicate you have done so to reduce confusion. Keep in mind, this may not be appropriate if your audience needs the ability to add numbers in the column or examine the data in more detail. Sometimes there may be null values in the data. However, no cells in your table should be blank. Blank cells may be confusing and unclear to your audience. Blank text fields should contain a standard and consistent entry such as unknown or not applicable. Blank number fields should contain a 0. or a dash if using the accounting format for monetary values. When including monetary values in your data table, there are several formats you may choose from. The two most common formats are the currency format and the accounting format. The currency format is often used for general monetary values, while the accounting format is more suitable for financial statements and reports. The currency format places the dollar sign directly to the left of the number, while the accounting format places the dollar sign at the left side of the cell, regardless of how many digits are in the number, and adds an extra space on the right side of the cell. There are also differences in how negative numbers and zero values are displayed. In the currency format, negative numbers are displayed with a negative sign, and zero values are displayed with an actual zero. In the accounting format, negative numbers are displayed within parentheses, and zero values are displayed with a simple dash. In either format, you may also choose to represent negative numbers in red to make them stand out better. However, keep in mind that emphasis may be lost if the table is printed in grayscale or black and white. Both formats for monetary values are acceptable, depending on the need, but consistency is key. Consult with your audience or customer to find out their preferences and how they intend to use the data. There are some stylistic choices you can make in the design of your tables that will help your audience read and understand the data better. One such choice is the use of borders and lines. When designing your tables, use borders and lines sparingly and avoid grids. Heavy grids can make it difficult to scan across rows. You want your audience to pay attention to the data and not to the design elements of your data table. Limiting borders and lines to the header and total rows allows your audience to see the information, not the table itself. If you have two different data tables close together in your report, you can add a thin border around each table to signal they are separate tables. However, table titles often provide enough space for separation. White space and fill can also enhance readability. You can add white space between rows by adjusting the height of the rows. Well-adjusted white space prevents the information in your data tables from appearing cramped and makes it easier to scan across rows. However, too much white space can take up space without providing any additional benefit, so aim for a balance. White space can also be created by using category labels only once, rather than repeating category labels on each row. The resulting white space serves to visually group the data categories together. Tables that are wide, with lots of columns, or long, with lots of rows, may need fill instead of white space. However, the shading of the fill should be subtle so it doesn't distract the audience from the data. You should also make sure there is sufficiently high contrast between the text or numbers and the background to enhance readability. Depending on the circumstances, you may choose to fill rows or columns. Titles, labels, and notes are also important elements of data tables because they provide additional context to help your audience interpret the information correctly. Every table needs a title to distinguish it from other data tables your audience might use. Titles set the stage and tell the audience what information they should expect to see in the data. Therefore, titles are placed at the top of the table so they are read first, and they should be descriptive enough to clearly convey what the table represents. If your table title is long, consider adding a subtitle to provide additional information. Columns should have clear, descriptive labels or headers, so your audience knows exactly what the data in each column represents. In some cases, your tables will require row labels as well. Column and row labels can be the same font and size as the data within the table itself, but the use of fill, lines, or semi-bold fonts can help set the labels apart from the data. It is best to avoid the use of abbreviations and acronyms whenever possible. If you do choose to use an abbreviation or acronym in your titles or labels, include their definitions in a notes section under each table. Notes provide additional information and context to help your audience interpret the data correctly. Notes can be placed directly beneath the table, on a separate tab of your workbook or dashboard, or even directly under the table title. Additional information found in a notes section may include the data source, the methodology used for analysis, including any exclusions or analytic manipulations, definitions of displayed units of measurement, such as time or distance, definitions of abbreviations and acronyms that may have been used, or anything else your audience may need to know to interpret the data accurately. Avoid using the Notes option within Excel workbooks, however, as they are easily overlooked and will not translate to print format, such as when embedding a table into a report or document. Data tables should be designed to ensure all audiences can interact with and learn from the data. Sometimes a table will be great for some, but inaccessible for others. Adhering to accessibility guidelines and requirements when designing your tables will allow them to be easily readable by everyone. We won't do a deep dive into accessibility requirements in this course, but we will touch on a few important aspects. Your audience may need to view data visualizations on a variety of devices, such as computers, tablets, or phones. Viewing tables on smaller screens can be especially challenging if your table is wide, with lots of columns, or long with lots of rows. Tables should be designed in a responsive way to optimize the table layout and allow the data to be viewed regardless of the screen size of the device your audience may use. There are programming techniques for designing web-accessible tables, but there are a few other things to consider when designing your tables to increase readability across devices. One way to address this challenge is to choose simple, uncluttered ways to present the data. Reduce the number of columns and rows in your table by presenting only the necessary information. If your table is still wide or long, you can make the table more readable by presenting it in a scrollable format. You can freeze important columns or rows to make sure that information stays on the screen while scrolling. Or consider the possibility of breaking up the information into multiple smaller tables. Not only can these practices allow the data to be more easily read on different devices, but they can decrease the cognitive load for your audience and increase their ability to find important information quickly. Your choice of font type can also affect a table's readability. Choose font types to ensure clear and consistent labels or headings, and easily legible text and numbers within the table itself. Serif fonts may look fancier, but their decorative elements can hinder readability. Sans serif fonts are more easily readable and therefore better suited for use in tables. Be careful with the use of bolded fonts as well. Semi-bold options are often a better choice as they are easier to read. Italicized fonts may also be difficult to read, so their use should be limited or avoided altogether. You should choose font sizes that are no smaller than 11 or 12 point, because smaller sizes may hinder reading flow for people using magnification settings on their computers. If you have the space, consider a font size of 14 point or even 16 point to ensure readability. Fonts that are larger than 16 point are generally not recommended, as larger sizes can also impede reading flow for people using the magnification settings on their computers. Once you have chosen the font type and size to present the data, be consistent with those choices across all your tables. For example, if you use 16-point Sego UI semi-bold for your table's title, 14-point Sego UI in the cells of the table, and 12-point Sego UI for the footnotes, use that same font type and size combination for all tables in the dashboard or report. Your organization may have standard fonts and sizes to use as part of brand and accessibility requirements, so make sure you follow those guidelines as you design your tables. Color can be an important part of data visualization design, even with data tables. High contrasting colors are a good way to highlight key points in the data. For example, you can use colors to make your totals stand out or to point out significant findings. Limit the number of colors you use, however, to avoid clutter and confusion. Additionally, some users with color vision deficiency or other visual impairments will have difficulty perceiving differences between certain colors, so provide color combinations that provide a high degree of color contrast. Use tools for checking color and contrast requirements, such as the Adobe Color Contrast Analyzer or the WebAIM Contrast Checker, or colorblind simulators to test your visualizations for potential accessibility issues. Color shouldn't be relied on as the only way to distinguish key data points, however. Variations in fonts and sizes can also provide contrast to highlight differences or significant findings in the data. Your organization may have a style guide that can be consulted when designing your data tables. Consult with your organization's accessibility coordinator, communications department, or other relevant department to find out if your organization has brand-approved guidelines or requirements. You can also find more information on accessibility tools and resources on the Texas Department of Information Resources website. Data tables have the ability to transform raw data into a structured, organized format and to present complex information in a clear and concise manner. They are a powerful tool for simplifying intricate datasets to aid in decision-making processes. Practicing good design in the development of your tables will ensure your audience can understand and use the data to support their mission and goals. You have now completed the course, Data Visualization with Tables. In this course, we talked about the difference between tables and charts and graphs, when tables may be the appropriate visualization format to use, and some best practices to consider when designing those tables to best present analytic results to your audience. For more information on the Texas Data Management Program, visit the Office of the Chief Data Officer website.